All right, so we have 11.1 simple interest. First thing they give us is the simple interest formula. All right, that's I equal to P RT. That's P times R times T, where I is your interest earned, P is your principal, so that's going to be your deposit or your loan. R is your rate, which is your decimal, and T is your time, and that's going to be in years unless otherwise stated. All right, are we good? All right, so calculate the simple interest earned in 1 year on a deposit of $1,000 if the interest rate is 5%. Give you a chance to write that, of course. So whenever you have any type of word problem, I always suggest that you would write down the given pieces of information first. So P is our deposit for $1,000. Your rate is 5%. Time is 1 year. And you want to know how much interest is earned in 1 year off that $1,000 at a 5% interest rate. Multiply 1,000 times 0.05 times 1. Good afternoon, good afternoon, good afternoon. All right, so $50 will be earned off of that $1,000 on that 5% interest. This P times R times T. Are you okay? All right, so the next one, calculate the simple interest due on a 3-month loan of $2,000 if the interest rate is 6% or 6.5%. All right, so notice that our month, we have 3 months loan that we're dealing with. It's not in years, so we're gonna have to convert it to years. So in the green, we're talking about how we convert it to years. So if we had 24 months, we know that's 2 years. The reason why we know that is because we take the 24 and divide it by 12. 12 months in a year, it gives us 2 years. So if it's not something divisible by 12, we still keep that same energy of dividing by 12. So that's what I did here. 17 months, divide that by 12, so that's 17 over 12 years. And you do the same thing as if we had weeks, 52 weeks in a year, so that's 19 over 52. And the only one you just have to be careful with is days. Days, we would use 360 instead of 365 because of what they call banker's rule. And so I read where it said 360 is just an easier calculation than using 365. And I also read where 5, is the number of legit holidays that are, around. So whatever way, it doesn't matter as long as you use 360 instead of 365 for days. All right. Everybody okay before I scroll up? All right, taking the given information from the problem. P was 2,000. R 6.5%. So convert that to a decimal is 0.065. Remember, you move your decimal 2 places to the left. And then we have 3 months. And would you put that 3 over 12? So plug that into the formula. P times R times T. 2,000 times 0.065 times 3/12. 32.50, $32.50. All right, questions. Scroll up. All right, so now this one, we're going to calculate simple interest due on a 2-month loan of $500 if the interest rate is 1.5% per month. So here I want us to be careful. You'll very rarely see this one. You may see one of these, but notice that our percentage is per month. All right, in this case. Now before it was APR, in other words, annual percentage rate. And if you don't see anything back there, they assume you know that you're dealing with your annual percentage. And some of them will say, annual percentage. But this one is per month. And so if it's per month, that means everything is dealing with months and in the terms of months. So you don't have to convert this. You can just leave it as 2. So this will be the deciding factor. What is your rate in? If it does not say anything, you can always be safe to assume that it's in years. That's why you have to convert your time to years. But if it says something like this, 1.5% per month, then you're in the units of month and you're okay to leave this 2-month loan as 2 and you don't have to put it over 12. All right, so make sure we're clear on that. Like I said, this is it right here. When you see something like that, that's what makes you do something a little different. Other than that, time is always going to be in terms of years. All right, so P is 500, R is 1.5%, which is 0.015. T is in months, so it's 2 months. Multiply those 3 numbers together, that'll give us $15. All right, questions. All right. Calculate the simple interest due on a 45-day loan of $3,500 if the annual interest rate is 8%. So it's an annual interest rate of 8%. All right, so P is 3,500, R is 8%, so it's 0.08. And then that 45-day, you write that over 360 because we're dealing with years, we're in terms of years. Once again, annual percentage rate. Plug those into the formula, 3,500 times 0.08 times 45 over 30, 360. problems? All right, so next variable we're going to introduce is your future value or maturity value. Both of those things mean the same thing, and they're used interchangeably. So if they're asking you for maturity value or if they're asking for the future value, both of those represent the letter A, are represented by the letter A. And like I said, they both mean the same thing. So it's the amount of money in your account after a certain amount of years, or the amount of money you owe after a certain amount of years. And once again, that's going to be represented by the letter A, future value or maturity value. And then all the other variables in this formula stays the same. R, T, and P will still be the same thing. So you can find your maturity value one of two ways. If you calculate the interest first, you can just add it to your principal. Or if you haven't calculated interest, you can just plug P, R, and T into this formula, and you will still be able to find out what A is. And in the red was just me reiterating what A is. It's the total amount of money in the account or is owed after T years. All right. So next problem, calculate the maturity value of a simple interest 8-month loan of $8,000 if the interest rate is 9.75%. All right, P is 8,000, R is 0.0975, then 8 months for T means 8 over 12. All right, plug those values in. Now, also pointing out, notice we want to calculate maturity. Nope, we all right. So we're going to find this maturity value both ways. I'm going to show you the first way, P plus I, then I'll show you the other way where you can just plug it into the formula. So this way, we're calculating I first. 8,000 times 0.0975 times 8 over 12 gives me 520. That's what's going on here in the red. Then if I add that 520 to my principal, that will give me how much money will be in the account after 8 months. So it's $8,520. All right, problems with that. All right, so let's calculate the other way using the other formula. So let's calculate the maturity value of a simple interest 3-month loan of $3,800. The interest rate is 6%. Give you a chance to write that down. $3,800 is P, 0.06 is R, 3/12, 3 over 12 because we have 3 months. So now, once again, we're going to use this formula right here. P times 1 plus RT. So got this in the green box because you can actually just put it in the calculator like that. Make sure you watch your parentheses. Whatever parentheses I use, make sure you use them. And that would be the safest way of putting it into your calculator. So it's 3,800 times 1 plus 0.06 times 3 over 12. Now, if your calculator can't just do it like that, then you have to do it in pieces. So you will multiply 0.06 times 3/12. That gives you 0.015. 1 plus 0.015 is 1.015. And multiply the 3,800 to it, give you 3,857. Like I said, you know, use your calculator, or certain calculators may not have this function of putting the parentheses like that. But if you do have that, you can put it in just like we have here in that green box, and it will take you right here without having to worry about the steps. All right, questions, any questions? All right. Also, what I emphasized in this problem, even though they didn't ask for it, if you want to calculate the interest and you had the future value and the principal, you can just subtract those two and get the interest earned. And so we had 3857 for the future value, 3,800 for the principal. Subtract those two, and that'll give you 57. And that's the interest earned. All right. Any problems? One more problem out of this section, then we'll go to the next. It says the maturity value of a 3-month loan of $4,000 is $4,085. What is the simple interest rate? So this time they give us the future value, the principal, the time, but they do not give us the rate. And that's what we have to find. So write down your givens. A is 4085. P is 4,000. R is the unknown. T, 3 months, so that'd be 3 over 12. A regular scientific calculator is fine. You don't necessarily have to go purchase like a TI-80 or anything like that. The type of calculator you want is the one that can actually allow you to put parentheses up, you know. In other words, if you can do this, you know, actually put the parentheses up, stuff like that, in your calculator, and then hit enter, then that's the type of calculator that you would want. Also, there are scientific calculators, online that will allow you to do that and raise stuff to the power. As long as you can put parentheses though in the calculator, that's one that's very usable. Not a problem, not a problem. So what I did here was I first found the interest earned. I took the 4085 minus 4,000, got 85. $85 interest was earned in the 3 months. Then I plugged it into this formula right here, all of the pieces that I know. So you're talking about 85 for I, 4,000 for P, and 3/12 for T. Now you remember, we're trying to solve for R. That's the one we do not know. And so what I did was I multiplied the 4,000 and the 3/12 to simplify it. 4,000 times 3/12 gives us 1,000. Then to solve for R, divide both sides by 1,000. That'll give us 0.085 or 8.5%, depends on how they want your answer in Weber sign. All right. Any problem before we look at 11.2? Yeah, it's not too bad. As long as you stick to the formulas, you should be all right. All right. So let's look at 11.2. Go all the way to the top. Okay. So same type of deal, just that we're looking at compound interest. So for loans of more than 1 year, the interest paid on the money borrowed is called compound interest. And then the frequency with which the interest is compounded is called the compounding periods. So it's going to be a new thing that's added to what we did in the last section. Let's scroll up. All right, so compounding or compound amount formula. All your variables are going to represent the same thing that it represented last section. So we have a new variable n that we're going to talk about in a second. But we have a equal to p times 1 plus r over n raised to the n times t power. So that n times t is an exponent. So that's why I say it'd be good if you had a calculator, because most definitely when we start talking about raising things to an exponent, maybe a little problematic if you're trying to do this by hand or in your mind. So yeah. So once again, A equal to P times 1 plus R over N raised to the N times T power. A is your future value, P is your principal, R is your rate, T is your time in years once again. And then our new variable N is going to be the number of compounding periods per year. Number of compounding periods per year. All right, scrolling up. Okay, so what's going to dictate what our number for N will be? What's going to happen is they're going to give us keywords to discuss how our money will be compounded per year. And then those keywords will give us that number. So annually means that N will be equal to 1. Semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. Daily, N is 360. Don't forget that 360 comes from the Baker's rule. All right. All right, so here we're looking at calculate the compound amount when $10,000 is deposited in an account earning 8% interest compounded semi-annually for 4 years. All right, so here we have P is 10,000, R 8%, which is 8.08, then T 4 years, and it says that it's compounded semi-annually, so that means N is going to be 2. Plug it into the formula. So what I have here in the box, 10,000 times 1 plus 0.08 divided by 2. That sum right there raises it to the power of 2 times 4. If your calculator has the capability, you can put that in your calculator and get your final answer. If not, just like I mentioned before, you have to do the stuff in steps. 2 times 4 will give you 8. 0.08 divided by 2 will give you 4, or 0.04. Add those together, raise it to the 8th power, and then multiply it by 10,000, and that'll give you your answer. And once again, if you can put it in this box, whatever's in this box, if you put that in your calculator, that would be the easiest way to go. Cut back on possible mistakes, especially when we start talking about going step by step. All right, any questions? We'll go to the next one. Make sure we're good. All right, so let's look at the next one. How much interest is earned in 2 years on $4,000 deposited in an account paying 6% interest, compounded quarterly? So the one thing we pointed out here is that we're looking for interest, the interest earned. So let's see how we go about doing that. First of all, as always, you write down your givens. P is 4,000, R 6%, 0.06. It's going to be done with 2 years, in 2 years, quarterly compounded. So that means N is equal to 4. All right, so plug it into the formula. 4,000 times 1 plus 0.06, 0.06, yep, divided by 4 raised to the 4 times 2 power. That's 4505.97. And remember, if you want to find the interest earned on that, A minus P, take your future value minus your principal, that original amount. So it's 4505.97 minus 4,000, and that's 505.97. All right, problems, any problems? All right, we're almost done. Next one is the present value formula. So this is one that you would use if they give you the future value and say, hey, I want to earn this amount of money. How much will I need to deposit? And so this is the same formula. It's just that it's solved for P. So it's the same formula we've been using in this section. It's just that P is solved for this time instead of A. And so this is what you would use if you have a desired amount out there that you're trying to get to, and you're asking yourself, how much would I deposit today, in the present, in order to get this future value? So that's what this problem is asking us: how much money should be invested in an account that earns 8% interest, compounded quarterly, and in order to have $30,000 in 5 years. All right, so write down your givens. So 30,000 is what we want to have. So that's the future. That's our future value. 0.08 for R, 5 years for T, compounded quarterly. So that's 4 for N. And if you plug into your calculator like this, 30,000 divided by, so that's the division bar right there. And make sure you use the parentheses where I have them. You'll be all right. That's 1 plus 0.08 divided by 4. This raises it to the power of 4 times 5. Use those parentheses around the 4 times 5 as well. And that lets us know that we need to deposit $20,000 or $20,189.14. You got to at least put that in order to get that 30,000 in 5 years. right, questions? Any questions? Scroll up. I think we got like 2 examples left. So next one, inflation is an economic condition during which there are increases in the cost of goods and services. All right, suppose your annual salary today is $35,000. You want to know what an equivalent salary will be in 20 years. Assume a 6% inflation rate. All right, so 35,000 is going to be your principal, your initial amount. Rate 6%. Talking about in 20 years, that'll be time. And here N, your inflation rate is annual. So we're going to let N be equal to 1. All right, so plug those values into the formula. That gives you 112,249.74 cents. All right. Any problems before we look at this last one? All right. Effective interest rate. The simple interest rate that would yield the same amount of interest after 1 year. We're talking about how do we find the effective interest rate. All right. So a credit union offers a certificate of deposit, COD, at an annual interest rate of 3% compounded monthly. Find the effective rate and then round to the nearest hundredth of a percent. All right. So to find this, we're going to let P be equal to 100. They gave us R, which is 3%, and then T is 1 year. And N is compounded monthly, so it's 12. So once you have those values, you plug it into the formula. That gives us 103.04. Subtract that from, subtract our principal from that. And that 3.04 will be our effective interest rate. All right, any problems, questions, concerns? All right. So that's it for 11.2 and 11.1. So our next block of work is going to be due at some point. We'll talk more about that on next class. It's 10.1 through 10.3, 11.1, 11.2. Next class will be a review day. I will not cover any new material. I'll just answer whatever questions you guys have, whatever questions you bring to the table on next class. So next class, once again, I won't cover anything new, but I will leave the class open for you to ask whatever you want to ask, or if there are any problems that you want to see me do again, type of problems you want to see me do again. So next class will be for that. Before we close out today, questions, concerns, comments, anything, anybody? Everybody good? Everybody straight? I hear somebody, you low though. Say it again.
Said I'm fine.
Okay, cool. All right. Well, if everybody's good, I'm good. Once again, I'll see you next class. Maybe you need to, maybe you should, take the time out, see if there are any problems that you want to see me do, tally them up, and we'll come back again on next week. I mean, not next week, next class, which is Thursday. All right. So outside of that, you guys have a good one. Appreciate you guys saying it in the chat as well. So you have a good one. Be safe, and I'll see you on Thursday.
Thank you, man. You too.
All right, you do the same.